Hello students, today's topic is importance of sampling. So this statistic quality control is based on sampling. To understand sampling, we have to first know what is a sample. So a sample is defined as a representative portion of a group which is taken as evidence of the quality level or character of the entire group. So let us consider there are some 1000 products. So from these 1000 products, we are going to collect some 10 products and we will check the quality of these 10 products. So based on the quality of these products, so if all the 10 have good quality or if all the 10 don't have good quality, we will accept or we will reject based on whether these 10 samples are adhering to the specifications or not. So based on these 10 samples, we will select or we will reject these 1000 products. So these 10 samples or these 10 products are called as the sample. So they are representing these products are representing these 1000 products quality. So that is what the definition is saying. So it is defined as a representative portion of a group taken as evidence of the quality level or character of the entire group. So there is always risk that the sample that is drawn may not be the representative of the group. So the sample may not be the representative of a group. That is the risk. So this aspect has led to different sampling techniques or sampling theory developments with the objective of ensuring selection of representative samples. So sometimes, so if we are collecting 10 samples here and if all the 10 samples are defective but the remaining samples or the remaining products in the lot are all good with quality, then what the problem is, seeing this 10 we will reject this lot. So that is the risk involved. So to avoid such kind of mistakes or such blunders, there are different sampling theories which will ensure selection of representative samples. So there are theories which will help us to select the samples accordingly. So the quality engineering has to be judicious in selecting the appropriate sampling method as well as the suitable sample size. So there are different types of sampling methods also. So while selecting the samples, we have to see the sampling method as well as the size of the sample is also very important. So now let us consider a box of 1000 parts, among which there are 100 which are defective. That is 10% of the parts are defective. So for example, consider a box of 1000 parts, among which 100 are defective. That is 10% of the parts are defective. So let us assume that the company policy is to reject the entire lot if 10% of the items which are drawn are defective. So if the company policy is to reject the lot if 10% of parts are defective. So among the 1000 parts, if 100 parts are defective, then the company will reject all the 1000 parts also. So that is the meaning of this sentence. So if a sample of 10 is drawn, there is no guarantee that one of them would be defective. So it can contain none, it can contain one, or it can contain several defective items. So if we are here from this lot, from the 1000 parts, if we are collecting some 10 parts are collected as sample, then there can be no defectives at all in it. There can be one defective, or there can be many defectives. So here we cannot predict how many defective parts the 10 parts or the 10 items which we have selected can show us. So if we increase the sample size to 100, then it may contain, or the odds of it containing the representative, that is 10%, would be much greater. So if we keep on increasing the sample size to 100, then odds that it may have 10% would be greater. So if we collect the sample size as 500, it is almost guaranteed that 10% of the drawn parts would be defective. So if sample size is 500, then it is guaranteed that 10% of the drawn parts would be defective. So we can say that the larger the sample, the closer it comes to being representative of the whole lot. So larger sample size are closer to being of the whole lot. So it is important that a representative selection is made in sampling. So this is called as random sample. So representative selection of samples is important. This is called as random sampling. So this is achieved only when the parts which are drawn at random from the lot. So in many cases, this is done by digging the individual samples out of various places in the bulk container. So here we will randomly pick up the parts from the whole lot. So let us assume that there is a bulk container, and what we will do, we will individually pick up the samples from different places in the container. When the parts can be identified by individual numbers, a random number table can be generated and used for picking the sample. So the parts are marked with different numbers. Then a random number table will be generated and we will pick the samples for testing. So random sampling is achieved by digging the individual samples out of various places in their bulk container. So from this we can infer or we can understand that the larger the sample size, the more representative is the sample of the lot from where it has been drawn. But there will be one negative or disadvantage of this type of sampling, which is to avoid 100% inspection and reduce inspection time and cost to a great degree. So what do we understand from this is, if the sample size is large, then the sample is more representative of lot. But the disadvantage is that to check large sample size, it increases inspection time and cost, as well as it negates the purpose of sampling, that is to avoid 100% inspection. So sampling is done so as to avoid checking each and every product. So when there is a large lot, we cannot keep on checking each and every product. So that is why we are going for this sampling. But here, if you want to take up larger sampling sizes, then it is almost equal to 100% sampling. So that will also cause increase in inspection time and as well as the cost. So the statisticians have recommended economic sampling plan to balance the two basic requirements. So economic sampling plan has been suggested to avoid 100% sampling and waste of time and money. So when we are planning a sample, we need to consider two factors. So what are these two factors? The first one is what is the least batch size which is accepted, or this is known as lot tolerance percent defective. What is the least batch size accepted or acceptable? This is known as lot tolerance percent defective, that is LTPD. The second factor which we have to consider is what is the risk involved in accepting a batch that is lesser than the lot tolerance percent defective in an optimistic sample. So this is known as the customer's risk. So what is the risk involved in accepting a batch that is lesser than the LTPD, that is lot tolerance percent defective in an optimistic sample? This is known as customer's risk. So there is a tolerance, that is the lot tolerance which is being given. So here we are going to consider two factors, that is what is the least batch size acceptable, that is known as the lot tolerance percent defective. So how much is the limit which is given for the defectives to accept the sample? So for example, in a 1000 sized lot, if there are only 100 defectives, then we are going to accept this lot. If they are more than 100, then we are going to reject this whole lot. So this is called as the lot tolerance percent defective. So if we are accepting the lot tolerance percent defective which is lesser than the lot tolerance percent defective in an optimistic sample, so then it is risky to accept the batch whose tolerance percent defective is less. Or if there are more defectives here and we are accepting the sample, then it is a risk. So this is known as the customer's risk. The most economic plan is the one that gives the required degree of protection to the producer for the least total amount of inspection per batch. The economic plan, that is economic sampling plan, is the one which gives greater degree of protection to the producer for least total number of inspection per batch. So the manufacturing process will produce when running normally average percent defectives known as the process average. The producer takes a risk that when running at the process average, a pessimistic sample will reject an acceptable batch. So if N, capital N, is the batch size or the lot size and small n is the sample size and R is the producer's risk, then we will get the total inspection for the batch, that is the total inspection is I in the long run for a given sample size is given by, so if capital N is the batch size, that is the lot size, small n is the sample size, R is the producer's risk, then number of inspections, total number of inspections per batch, that is I, can be written as I for a given sample plan. I is equals to small n, that is the sample size, plus capital N, lot size, minus small n, that is the sample size, into R, that is the producer's risk. So it is seen that I is the function of batch size and R is the function of sample size. So if I is plotted against sample size for a given batch size, there will be a curve obtained and this gives the most economic sample size for a given batch size. So here I is the function of batch size and R is the function of sample size. So if I is plotted against sample size for a given batch, then we will obtain a curve. So that curve is something like this. Average total inspection for batch. So here it is. Then this is the acceptance number. So this is inspection per batch versus batch size graph. So this will give us the most economic sample size for a given batch. So there are different types of sampling methods. The four popular sampling methods are, the first one is the simple random sampling. The second one is the constant interval sampling. The third one is the stratified sampling. The fourth one and the last one is the cluster sampling. So we will discuss what these sampling methods are one by one. The first one, that is the simple random sampling. So simple random sampling selects the samples by methods that allow each possible sample to have an equal probability of being picked and each item in the entire population to have an equal chance of being included in the sample. So here by this sampling method, so each possible sample will have equal chance of being picked. Each item in the lot or the entire population will have the equal chance to be picked or to be included in the sample. So the easiest way to randomly select a sample is to use random numbers. So these numbers can be generated either by the computer programmed to scramble numbers or a table of random numbers. So here in this method, it selects samples by methods that allow each possible sample to have an equal chance or equal probability of being picked, or each item in the entire population to have an equal chance of being part of the sample or being included in the sample. Random sampling is done by using random numbers. So these numbers can be generated by computer scramble numbers or by using table of random numbers. The next type of sampling which we are going to discuss is constant interval sampling. So this sampling is done based on the sequence at which parts leave the production operation. So this sampling is done based on the sequence at which parts leave the production process. So the sequence may be every third part or maybe even every 10th part. So the sampling plan is done based on the experience of a statistical control professional. So for example, if the lot size is 200 and 10 samples are needed, then the sampling interval is given by 200 divided by 10. So if lot size is 200 and samples needed are 10, then the sampling interval is 200 divided by 10, that is 20. So the point in the production at which the first sample is drawn may be determined by a random number in the interval 1 to 19. So the first sample which is drawn from the point in production may be determined by a random number between the interval 1 to 19. So by following this, the other samples are drawn according to the selected interval. So in this case, there are 20 parts. Suppose the first number turns out to be 7. So here from the 20 parts, that is the sampling interval is given as 20. So from 1 to 19 any random part can be selected. So if we see that instead of 20 the number is 7, then the part numbers to be drawn are 7, then 27, then 47, then 67, then 87, then 107, then 100, 127, then 147, 167 and 187 if the lot size is 200. Okay, so this is how we select the samples in the constant interval sampling. The next type of sampling is the stratified sampling. So in certain situations one continuous sample may not produce the desired information. So one single sample may not provide us the desired information. So let us consider the example that the production runs of one part divided among different machines or different operators. So the production is carried out of the same part, same type of parts on different machines. So in this case the sublot sizes may differ. So what we should do, the sample size for each sublot must be determined separately. So stratified sampling is appropriate when the population is already divided into groups of different sizes and we wish to acknowledge this fact. So let us consider that there are parts, same type of parts which are produced under different machines and different operators. So for such parts we have to make sublots. So for machine, let us consider there are three machines, machine A, machine B and machine C. So these are different machines and they are operated by different operators. So from this machine the parts which are being produced have to be sampled, or we should take samples from this part. So the parts, how many parts we are taking from this part or from this machine is different from the machine B and from machine C. So this is called as the sublot. So for such cases where the population is already divided into different groups of different sizes, the population here, see the total number of parts which are produced by the three machines are same parts are produced and they are giving a total number, but they are divided into different types of machines, that is the different groups. So for such cases we are applying this stratified sampling. So let us assume that a part can be machined on any of the four machines of similar type but of different ages. So in order to carry out the inspection of dimensional accuracy, random samples can be drawn from each of the four machines by giving weight to the age of the machines. So stratified sampling is applied when parts or when the population is already divided into group of different sizes. So this is about the stratified sampling. The next and the last type of sampling is the cluster sampling. So in cluster sampling we divide the population into clusters and select random samples from each of these clusters. So here we divide the population into clusters and select random samples from each one of these clusters. So This type of sampling is used when the lot size is very large. So in such cases, we will want to divide the lot size, or we want to divide the population into small clusters, and again we are going to take samples from each of the clusters by assuming that the cluster is a representative of the entire population. So, for example, if a motor manufacturing company wants to estimate, the motorcycle manufacturing company wants to estimate average number of young male per house in a large city. So, what will they do? They will use a city map to divide the territories into clusters. So, they will divide each area, for example, in a large city, they will divide different areas into clusters, and then they will choose certain number of clusters for interviewing. In Bangalore example, there is Jainagar, there is Shivaji Nagar, there is JP Nagar. So in the big city they will select few areas and they will interview people in that areas. So every house in each of these cluster will be interviewed. So a well designed cluster sampling procedure can produce a more precise sample at a considerable less cost than that of the random sampling. So the population is divided into well defined groups in both the stratified and the cluster sampling method. So stratified sampling is used when each group has small variation within itself but wide variation between the groups. Cluster sampling is used when there is a considerable variation within each group while the groups are essentially similar. So here, when there are large populations, that is the cluster sampling. So this is all about the importance of sampling and different types of sampling. I hope you have understood the topic. Thank you.